Hi everyone. Welcome to our next lesson where we're going to talk about different kinds of tables and graphs. So the two graphs we're going to start with are bar graphs and histograms. They really look very similar. The difference is bar graphs tend to use qualitative data, which is more like words or letters, and histograms tend to use quantitative data, which are numbers. That's not always true. You could have a bar graph that uses numbers. There's a specific stipulation for histograms, and it's that the numbers should be on a continuous scale. Okay, so let's do some examples so I can show you more of what I mean. So let's say there were 25 volunteers for a medical study, and they were given a blood test to obtain their blood types, and here is the data. So let's create a bar graph for this data. It's common to start with a frequency table, so I'm gonna make a quick frequency table. Let me zoom out so you guys can all see this. Okay, so it looks like there are 4 different blood types here. So I'm going to have 4 different types in my table. So these are blood types. And then on the right, I'm going to just put the frequency count, which means how often those blood types occur. Okay, didn't realize you can't see that. Okay. So let's call one is A, another is B, another is AB, and another type is type O. And now we're just going to count how many type A's do you see? So I see 5. How many type B's? I see 7. AB's? Looks like 4, and the rest should be type O blood, and I see 9. And we can count these to make sure that we got all 25, just to make sure it adds up. All right, so let's see. We have 9, and 9 is 18. 18 and 7 is 25. So that's good. It checks out. We expected to see 25 because the problem shows that there's 25 people. So now we can make a bar graph. So now we have the relative frequencies, but notice this is qualitative data. So when we make our graph, it doesn't matter which labels we start with first because there's no inherent order to those blood types. So I'm just going to go in the order I wrote them in my frequency table. Start with type A, then we'll go type B, then we'll do AB, and then we'll do type O. And if it's an appropriate bar graph, I should label these. So we'll label this blood type, just like I did in the frequency table. And over here, this will be frequency. Okay, and I mean, the numbers are in the ones. No number is higher than 10, so we could probably just scale this by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Highest number is 10. Okay. And now we're gonna draw some bars. So let me make this a little bigger so you can see me. So now let's draw. Doesn't matter what color. So we know that there are 5 people had type A blood. So here's a bar going up to 5. 7 people had type B. So here's another bar going up to the 7 mark. 4 people had type AB. So that looks like it's about right there. And 9 people had type O. So up here. Okay, and so that's a basic bar graph. You're showing the frequency counts of various categories down here. And this particular example is about blood type. So we could conclude that the majority of people have type O blood, which does happen to be the most common blood type among humans. But you can see it quickly in a bar graph. Now, what's important to note about bar graphs is that because they're qualitative data, they don't have to be, but this current one has qualitative data. These could have been put in any order. So usually we don't talk about, whether this is increasing or decreasing or something because there's no numbers down here. It doesn't make sense to talk about increasing when there's no numerical data down here. There will always be numbers up here because this is a frequency count. You're showing how many people or things exist in different categories. So the next example we're going to look at is a histogram. So if you look at this histogram shows the number of people who went to the movies in the past 2 years. And you see here, these bars are all touching compared to the example I just did where I made it, my bars are not touching. Like if I shade them in the way theirs are shaded in red. So notice I left a gap between all of my bars to remind myself that this is qualitative data, that the bars don't have to be touching because they don't mean anything to be touching. But in a histogram, because there's numbers down here, this is saying so these are the number of movies attended. So if I asked you, like, how many movies have you seen in the past 2 years? And you said 5, then you're counted in this first bar of people, 7 people that have seen between 0 and 10 movies in the past 2 years. So that's very different than the bar graph because now the scale down here on the x-axis is quantitative. And in this case, it's continuous quantitative because it goes right from 10 movies and the next bar starts at 10 movies. So if you raised your hand and said you saw exactly 10 movies, you would be counted in the second bar, not in the first bar. And so because histograms have that continuous scale, we do need some kind of convention that tells us, like, where do you include the endpoint? And so the convention is so see how this starts at 0 and there's like I don't know if you can tell, I can make this a little bigger, but there's a square bracket here and there's a parentheses on the right hand side of the endpoint. That's because the endpoints always get included. Wow, I can't phrase this the appropriate way. This left endpoint, 0, is included in the first bar. That means the right endpoint should not be. So the left endpoint is included in the second bar. The left endpoint is included in the second bar. Right, so in other words, if you saw exactly 30 movies, you would be included in this bar because it says 30 to 40. You wouldn't be included in the 20 to 30 because this is every person who has seen between 20 and 30 movies, not including exactly 30 movies. So that's what a histogram is. And you might say, well, that's kind of silly in this example. Why don't they just put 20 to 29 movies? Because you can't see half a movie. And that's true. We could put 20 to 29 movies, and in the next bar we could put 30 to 39 movies. That would make this a bar graph, which isn't completely continuous because you're missing the decimals in the middle. So this is probably a poor example of the idea of a histogram, but histograms with true continuous data would have decimals in the middle. Like if I asked, like, what's your height? And like how many people are between the height of 0 to 10 meters, or I guess meters won't make sense, but or something like that, where if this were a height, then it would make sense to say, like, well, where do you put 9.55? And it would go in the first bar all the way up to 10, but not including 10. Okay, so that was a lot just to talk about histograms and bar graphs. You don't really need to know the difference between those two words, but it helps to know that they're both bar graphs in some way. A bar graph is more common. You can only use bar graphs for qualitative data. You can't use a histogram. And in histograms, when you have numerical data or quantitative data, then your bars should be touching to show that you're on a continuous scale. Okay, so let's answer a question. Looking at this histogram, how many people have seen at least 60 movies? So try that question now. So at least 60 means 60 or more movies, and 4 people have seen between 60 and 70 movies, 2 people have seen 70 and 80 movies, and 1 person has seen between 80 and 90 movies. So if you just add those numbers up, 4 plus 3 is 7, so 7 people have seen a total of at least 60 movies. How about number 3? Based on the histogram above, can you determine how many people have seen at least 55 movies? And your answer should be no, because you know 6 people have seen between 50 and 60 movies, not including 60 movies, but you don't know exactly who has seen more than 55 movies because this is an interval. So we don't know. It could be that all 6 people in here have seen 52 movies. Exactly. Or it could be that 3 people saw 52 movies and 3 people saw 58 movies. Or it could be something very different than that. So a histogram is a little bit limited because it doesn't give us the exact data points for the entire distribution. But with limitation comes some other benefits, and the benefit is we see the whole distribution very quickly. instead of having to read all 200 numbers. We see it, in a snapshot. Okay, so the last thing that we're going to do is called a box plot. So now you're familiar with bar graphs and frequency tables, which are used to help you draw bar graphs. And you're familiar with histograms like we just saw. So the last thing to do is a box plot. So I'm going to grab an eraser and use the board. Okay, I'm just going to write these numbers for myself. 2, 5, 5, 6, 6, 7, 7, 8, 9, 10. 8, 9, 10. Okay, could have written those in a better way, but all right. So a box plot, let me back up so you can see all the numbers. A box plot is a plot that shows you a visual understanding of how the data are spread out. And so a box plot is drawn by figuring out different quartiles, which stand for certain percentiles in the data. So what is a percentile? A percentile means, like if I am in the 74th percentile for height, that means I'm taller than 74% of everybody else. I wish that were true. That's not true. I'm about average height, so I'm about around the 50th percentile in height. When I took the subject matter GREs, which is like a SAT type score for graduate school, and I took the math specific version because I was a math major and I was going for a math master's, I scored in the 11th percentile in the country. So that means I only scored better than 11% of everybody who took that test. So that's very low. So if you scored in the 90th percentile, then you scored better than 90% of everybody who took that test. Okay, so that's what a percentile means. So if you're trying to find percentiles of a data set, there are 3 key percentiles that are, like kind of road markers that are very common to talk about data sets. So they are called Q1, which is the 25th percentile. This is also called the first quartile. Q2 is the 50th percentile. Oh, whoops. I meant to put 20, not 25%, 25th. This is the second quartile. And then there's Q3, which is the third quartile, which represents, as you would have guessed, 75th percentile of the data. So if you can find the first quartile, that means you know the value at which 25% of the data are at or below that value. The 50th percentile means 50% of the data are at or below that value. And the 75th means 75% of all the data points are at or below that value, whatever it is. So a box plot shows these percentiles, these key percentiles, plus 2 more important numbers. A box plot also tells you the minimum value and the maximum value. And in general, the way a box plot shows this, you can draw your box plots vertical or horizontal. I'm going to draw a vertical one on here since I've written all this vertical. The way they look in general is they look like this, starting with Q1 as a box, ending that box on Q3, and having 2 whiskers showing you the minimum and the maximum values. So these are called whiskers at the end. So your whiskers go up until the minimum value and up until the maximum value. And the box only goes from Q1 to Q3. And then your Q2, which also happens to be your median, it's the middle of the data. So if you want to add that as a note here, it's also the median. You just put a line there showing exactly where the median occurs. So we're going to do this example with that data set I put up at the top. We're going to create a box plot for those numbers. Okay, so the first thing that we're going to notice is the minimum value is 2 and the maximum value is 10. So let me zoom out so you guys can see. So this is the minimum value. Here is the maximum value. Okay, so then 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 points here. That means the 5th point would be the middle. So 1, 2, 3, 4, 5. Here is your median, which is also Q2, which you now know. Here's your median. Because it splits the data right in half. You've got 4 points on this side and 4 points on that side. So there's your middle. And then I wish I could get that weird light to go away. And then you also have your Q1 and Q3. Q1 is the 25th percentile, which is the middle of the lower half. Q3 is the 75th percentile, which is the middle of the upper half. So the middle of these 4 points occurs right here. So Q1 would be the average of 5 and 5. 5 plus 5 over 2, which is still just 5. So that's Q1. And then Q3 would be the middle of all the right points. And the points on the right, there's 4. 1, 2, 3, 4. So that would occur right here. So here's Q3. It's 8 plus 9 over 2, which is 8.5. Those numbers are called a 5-number summary. So let's put that here in another color. The 5-number summary for this data is 2, 5, 7, 8.5, and 10. And again, this is the mean. This is Q1, Q2, Q3, and then the maximum value. So that's the 5-number summary. And we use those same 5 numbers to draw the box plot. So I'm going to draw it. I'll draw it horizontally so that you can see both. You can draw it vertically or horizontally, whatever you prefer. So if we draw it horizontally, I'm going to put a scale on here that goes by ones, just because the numbers look like they're between 1 and 10. So we'll start at 0, and we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to draw my box plot above this scale. So we'll put exactly where all these numbers occur. So the min is at 2, so that's your first whisker. Q1 is at 5, so this is your box. Q3 is 8.5, so the box goes up to 8.5. I guess I could make that look a little bit more uniform. Okay, apparently I can't. Okay, up to 8.5 right there. And then the max is 10, so the other whisker goes up to 10. This whisker goes all the way down to 2. And then to represent the median, which is the middle, it's at 7, so there should be a line right here at 7. And so there's our box plot representing that data set. The data set consisting of 2, 5, 5, 6, 7, 7, 8, 9, and 10. Okay, so we're going to do one more question about box plots to make sure we understand how to interpret them. So let's say I give you this box plot, and Consumer Reports rated automobile insurance companies and listed premiums for top-rated companies in several states. So here are those 3 states. This shows a box and whisker plot for annual premiums for urban customers. And let's answer some questions. Which state has the lowest premium? So the lowest means the minimum, and it's kind of hard to see. It looks like it might be California, so it's definitely not Pennsylvania. Looks like it might be California, so let's put the lowest is California, which put Cali. The highest premium is definitely Pennsylvania. And again, I'm looking at the whisker, the highest whisker, right, because that would be the maximum value. So remember, the box and whiskers, they start minimum is the top whisker or the leftmost whisker, and then the maximum is the rightmost whisker. or the lowest whisker, depending on how you drew your scale. Part B says, which state has the highest median premium? Okay, the median is the line inside the box. So here it is for Texas, here it is for Pennsylvania, and here it is for California. And Pennsylvania is furthest to the right. So Pennsylvania has the highest median because the line is furthest to the right on this scale down here. Even though we're not given numbers, this is further to the right. Which state has the smallest range of premiums? Okay, so the range is the same range we calculated last lesson. It's the maximum minus the minimum. So the smallest range means the tightest entire box and whisker plot, which means California. So this min and this max, if you subtract those two numbers, that would be a smaller difference compared to Texas, which looks very spread out, and compared to Pennsylvania, which looks very spread out. So the smallest range is California again. And this was something I didn't talk to you about. The interquartile range, which we should add that to our notes, is Q3 minus Q1. So let me include that in our notes here. The interquartile range, sometimes people abbreviate this as IQR, is found by doing Q3 minus Q1. So that is yet one more measure for variation. So in the last lesson, we talked about range and standard deviation. And now you have one more measure for how things vary. You have the interquartile range. The interquartile range can be used when there are outliers in your data, because if you look at the box plot, the interquartile range is only Q3 minus Q1. So any outliers that would be in the, obviously outliers lie on the outsides, so they're either in the lower 25% of the data or in the upper 25% of the data. Either way, they won't be counted in the IQR. So the IQR is not affected by outliers. The range is, and the standard deviation is slightly, but the IQR is definitely not. It is, by definition, made to not include outliers. So, if you look at the last question, which state has the smallest interquartile range instead of just the range? Now you're looking for the smallest box, and the smallest box looks like Texas. So, smallest IQR is Texas, because the Q1 here and Q3 here, it looks to me like they're a little closer together than Q1 here and Q3 here, and Q1 here and Q3 here. This looks like the biggest box out of all of them. A little tough to see some of these because some of the numbers look kind of close, at least for part A, the lowest one looks really close. So if you said Texas instead of California, I would give you credit for that because it's hard for me to see which one is actually the lowest. But in general, it's important to know what you're looking at when you read these. So what you're looking at is the lowest value is your whisker on the left. That's your minimum value. Q1 is your 25th percentile. The line in the middle is your Q2, or your median, or your 50th percentile. The box ends at Q3, which is your 75th percentile of the data. And the whisker on the right goes all the way up to the maximum value that's present in the data. It doesn't mean that all these numbers here are included in the data. It is just showing you how far away the maximum is from the rest of the data. Okay, so that concludes our lesson on these different kinds of charts. In our next lesson, we're going to talk about just how to go about reading statistical information that we might see in our everyday life, like bar graphs we might actually see in the news, or charts we might actually see on social media, or things like that. And we'll make sure that we're interpreting them correctly and know how to read them.